Before giving way to the speakers, I would like to introduce IACDS in case any of you do not know us. The International Association of Concrete Drillers and Sawers, IACDS, is the organization representing the associations, companies, and professionals of the concrete drilling and sawing industry around the globe. IACDS brings together the industry experts on regular basis, meeting and working together on the common goals since 1999. It is a platform that brings together the key actors of the trade and represents internationally the national concrete drilling and sawing associations and specialized contractors and suppliers. To this purpose, the association prepare events, publications, and other initiatives to share industry knowledge with stakeholders and other entities linked to this trade. Before COVID times, and hopefully soon again, the IACDS organizes every year a few activities and events to bring together the industry and supports its national associations in their own activities, conventions, meetings, workshops, trade fairs, and so on. IACDS promotes different initiatives to teach and demonstrate what can be done with the techniques and products used for cutting and sawing. Among these initiatives, the most notable is the Diamond Award. The Diamond Award is an international competition which is organized every 3 years for the concrete sawing and drilling industry to improve the visibility of the companies through their jobs as well as to demonstrate their professionalism. From IACDS, we were implementing a series of initiatives to continue with the dissemination of the activities and services developed by IACDS members. Webinars are short and an educational session about 1 hour, hosted online and broadcast live. They are like representation style session with up to 3 speakers sharing slides, videos, images with the participants. Using a specific platform, webinar participants can watch the presentation and follow the speaker's explanations, as well as interact through a chat and ask their own questions. The webinars will be given in English. All the webinars will be recorded to publish later on an online academy, and their presentations will be transformed into an e-publication. If you need more information, please do not hesitate to contact us through the contact information on the screen. Thanks again, and we hope you enjoy the webinar.
Hello, good afternoon. My name is Jose Blanco. I'm the Secretary General for the IACDS, and after the introduction of our President, Michael Findays, I have the task today to moderate and to share the questions. So first things first, welcome everybody. Good afternoon for you if you are in Europe. Good morning if you are in the US, and if you are in the East, probably good late evening already. So thank you very much for participating on this webinar. And today we're going to talk about the temporary fixation of the tools that we use for concrete sawing and drilling. And to do so, we have with us an excellent speaker. The speaker is going to be Martin Goedeke-Meyer from the company HLT. And he's going to speak about a topic that we already covered on a guide made before. This webinar is possible thanks to the cooperation and support of all the IACDS members. And after this webinar is gone live, it will be published online. Without further ado, I'm going to ask Martin to turn on the camera.
Hey, Jose.
Hello, Martin. Once again, thank you for this special effort that you are making today to be on the presentation. And I leave it to you. The floor is yours.
Okay, thank you. Thank you, Jose. So welcome, everybody. Short introduction to myself. My name is Martin Goedeke-Meyer. I'm working for the company HLT, and I'm responsible there for the global diamond service contractor segment. Mostly, of course, for the diamond part of it. But of course, as we are originally a fastening company, there's also a lot of effort we put into anchoring. And I would like to give you today some advice in how you can actually act professionally, or more professionally even, on the job site regarding anchoring, and we go into that right away. So what I will talk about today is first the purpose of that meeting we have here, the trainings, the goals of this training, the synopsis. Then I will go into application basics, covering the base materials, the diamonds, the coring application, and the sawing applications. Then we will touch some anchoring basics, how anchors fail, what anchor types we can use, and some little words on the setting procedures. And then I'll end the call with recommendations and coring and so on. Now, what the purpose of this meeting is actually to show you how to properly fix coring tools. We all believe we know the best how that works. But there's some indications I want to give you. You might look at the whole thing in a little bit different way. I will talk about coring tools, also wire saws, fixing to concrete, and we will talk about characteristic load profiles of the applications and the proper choice of anchors. The goal would be to understand the loads. The correct would be to correct some wrong perceptions we have on coring. The goal would be to understand critical factors and their effect, the geometry of the material we use, and the distances from the coring, the sawing tool to the rig or the fixation, and to in the end to know which anchors to use. What I will talk today about is really about the application and the temporary fixing. What I will not talk about today is actually something we all have to do, which are the lifting applications when we put concrete blocks aside. And I will also not talk about permanent anchor installations. If you have interest in a training on these things, you can let us know, and the IACDS in this case. And we might also be able to provide you a proper training if you want on those things. But today, we really fix on the application, coring and sawing, on the base materials to be used, on the edge distances, on the application-specific data, and the proper anchor setting procedures. Now, when we look into the applications, then first of all, we have to talk about the surface, the base material we are anchoring to. Usually, our knowledge on the base material, on the concrete or whatever we believe it is relatively poor. We don't often know about the type, the tensile strength, and the conditions of the concrete, and it varies very, very strongly by the application. The use of an anchor type, which is covering a wide range of these concrete types, is therefore advised. It makes sense to have something which can be used more universally if already the base material we are facing is poorly defined. When we look into temporary fixation on masonry, lean concrete, or other surface materials which are not exactly concrete, then we would of course have to use different anchor types, but we touch upon later. What is ultimately influencing very much what we do on the anchoring side are the conditions of the inserts. So if the core with saw blade or wire is really blunt, we see that the forces which we have to exert, and everybody knows how coring works. When you have to press the handle on the core rig really, really hard, you know that the core bit might be very blunt, and the effect is that the forces acting on our equipment when we use blunt blades, wire or core bits is factors higher, not just some percent. It's really 2 to 3 times higher, and that of course we have to consider as well when we are anchoring. We have to consider how and what quality our material actually is. There's something which is also quite important on the anchor. That's actually tool maintenance. So damaged or poorly maintained equipment can cause very strong vibrations and dynamic loads on the anchor, which are then, of course, putting much more forces, dynamic forces in that case, on the anchor, which also would require that we probably would have to go one size bigger, or that we would properly maintain our material. So in case that we have an imbalance on a saw blade, or an imbalance on a core bit, or a not straight core bit, the safe working is actually much restricted. Larger anchor size, deeper embedment depth of the anchors would have to be chosen in order to use such material, or better to avoid using that material. The loads we are talking today about are normal loads, so loads which are in the direction of the anchor. When we look into different applications like lifting out blocks, we usually talk about shear stresses, and that requires an entirely different look at the whole thing. Today, we are actually happy to be able to cover all the mathematics with normal loads in direction of the anchor, which makes the math, which is probably already a bit complicated, actually much easier to understand. Now we look at the base materials, and very quickly going through that. When we're looking about concrete or reinforced concrete, we would actually use mechanical, we would call it medium duty or chemical anchors. On cracked concrete, we should actually use anchors which have a certain approval or resistance for cracked concrete in the tensile zone. On masonry, we would have to use chemical anchors or through bolting. Aerated concrete, lightweight concrete, and natural stone would actually go in the same direction. So there we cannot recommend mechanical anchors, but in these concretes, chemical anchors or through bolting have to be used to have a safe operation of tools. When we look into cracked concrete, you probably have been asking yourself what that is. You can see it on the picture very, very nicely. Concrete can actually compensate only for compressive stresses. So when you press on the concrete, that stress is tolerated very nicely by concrete. When you pull on the concrete, this does not work. So on the tensile loads, and you see that in the middle of the hanging beams or above the columns, the concrete will crack. If there's rebar or not, concrete will crack in these zones. And in these zones, we should consider actually using anchors which can tolerate cracked concrete. Best advice to avoid anchor failures due to the concrete conditions is to choose anchors with an approval for cracked concrete, which all of our anchors, of course, have. And we will show you which anchor types would actually be best for these conditions. Now, when we look into the mathematics a little bit for the first time, we can do two things, right? I have put the math behind everything in the third box from the left, but in that presentation I will not go into details. I would just tell you basically three things. One thing is, if you look at the diamond should be sharp. How can you judge it? Well, if you take a courbit, you hold it to the light and you turn it a little bit, you see the reflection jumping on the diamonds at the very given moment. That means the different facets of the diamond are reflecting the light when you turn it. When you have a blunt bit, then the reflection changes gradually and you can clearly see that the diamonds are round. What is good for us is a sharp courbit, it's a sharp saw blade, it's a sharp wire. What is bad for us is a blunt courbit, wire or blade. Why is that? When you look at the math, you can see that if the sharpness of the material goes down, then actually the forces we have to exert on the courbit or on the blades to advance are higher, and they're not a little bit higher. They are easily a factor 2 to 3 higher, and that clearly is reflected entirely on the courbit, on the anchor. So the anchor will be loaded much more if you have a blunt bit than when we have a sharp bit. And the only recommendation we can give you actually in that sense is keep your insert sharp. Select the proper specification. Select the right gear to saw or gear or core on. Use a good quality machine. We have all experienced that blunt bit are needing very high pressure, and that can pull your anchor at the moment where you really can't have this. Now, when we look at one thing more, which is actually affecting the safety we have, it is the position of the anchor versus the rig, and that would be given as actually the difference between, when you look at the picture, between the distances A and B, right? If distance B is very short and distance A is very high, then we have an extremely higher load, a lever factor, which is actually pulling on the anchor much more than we believe. So what we should do in any case is that we put the anchor on a core rig, on a rail support for the sawing, and on the pulleys for wire sawing as close to the insert as we can, as close to the corbit, as close to the saw blade, as close to the wire as we can, because that will limit our pulling forces a lot. And how much that can limit our pulling forces, I can show you actually on the next slides. Right, this one clearly an application which is very bad. Huh? So a very long A to a B. Clearly to understand that pulling here on the core rig actually can pull the anchor in a very easy way. Now, when we look at the given of a core rig, you can see that if you have an anchor positioned somewhere in the middle of a core rig, now here you have the HD30 from my company, you can see that for small core bits, almost everything is in the red zone. The red zone would actually indicate that the anchor which you mostly use, an M12 anchor or a half-inch anchor, which most of my customers use for coring applications, is actually overloaded. Even if you used correct gear on a 52 or 2-inch millimeter core bit, the anchor is already overloaded. When we go to a 4-inch or 1 or 2 millimeter core bit, you see that if we are operating in the fastest turning gears, we're still okay. But if we choose a gear which is a little bit high, we come immediately into the red zone. And probably for many of us, surprising is that on a 202 millimeter core bit, we almost never can reach the red area. So there, where we believe we could use a small anchor, we cannot. That means on the small core bits. There, where we believe we would have to use a big anchor, on the big core bits, we actually could use a small anchor. So that is very, very important for me that you memorize. When you have an application with a small anchor, then you cannot use that for small core bits. You can use small anchors only for large core bits, but we clearly do not recommend that. We recommend that for any heavy coring application, like with the DD350 or any tool which is 3 kilowatt and more, you use an anchor which is a size bigger, an M16 or a 5.8 anchor, because those anchors give you the additional safety which you need to have really safe operation. So memorize, small core bits means actually big anchors in any case, whatever tool you use. When we look into the sawing application, actually the same thing is applicable. You see here the cross section of a Hilti wall saw mounted to a rail support to the wall, and the forces which are acting are very similar to the coring application. What is essentially important is that the anchor is put as close as possible to the blade, so means up, so that the distance B becomes small and the distance C becomes as big as it can be. When you're using rail support, like for the hydrostress saws, where you're extending downwards and where you have the fixation actually at the wrong side of the blade, then you should actually probably consider taking bigger anchors than you do today to have additional safety. When we look at how high the loads are on a sawing application, you see here depicted on the bottom actually a rail with a left fixation point, which is represented by the red loads, and a right fixation point, which is represented by the green loads. And you can see here that the highest load we actually are seeing when we are at the rail support, and the loads are in an order of up to 9 kilonewton, which is exactly what a half-inch anchor still can tolerate. So we are also at a sawing application at the limit, while the good thing is that we have actually 2 anchors in place, which gives us some additional safety and redundancy. When we look into wire sawing, then we can clearly say that in this application, dynamic forces are governing. The static pulling forces of the wire on the wire is very low. It's only in the order of 1 to 2 kilonewton, so really low forces. But and these forces, if something goes wrong, they are actually released if the wire ruptures when it blocks, or they are released when the wire doesn't rupture and the concrete block is indeed squeezing the wire. Then they are released by anchor breakage. We have seen really high forces here, small anchors actually being pulled out and pulleys flying a long distance away. So it's relatively critical when such an anchor comes out, because then the pulley pair can fly away and can hit you. So what we have to expect here are forces which are exceeding clearly the 10 kilonewton. So that in that application as well, we actually should be choosing a little bit bigger anchor size to have really safe operation of our equipment. Now, when we go into the anchor basics, there I would like to start with vacuum base plates. Vacuum base plates are not very often used in our industry, but they give you, of course, the advantage when you have to work on a nicely polished marble floor where you have to core a hole that you do not have to additionally set an anchor. Sometimes people also who have to do some sewing applications under these conditions, refurbishment in perfectly outfitted buildings where you have natural stone or tile floors, can be used with vacuum base plates, but there are some restrictions, right? The vacuum is not as safe as an anchor because it depends on the vacuum pump actually creating a proper under pressure on the plate so that the plate stays in place. Which means that overhead applications are restricted to the fact that you additionally have to fix the plate. Wall applications also require additional fixation, and we restrict it also to use the use without automatic feed. So we don't allow customers to use those vacuum base plate with automatic feeds on our coring tools because they can exceed the under pressure and can actually lift that plate. So what I just can say here, vacuum base plate fixations are generally more prone to failure due to potential power outages and vacuum leaks due to irregular concrete surfaces, and there's always additional precaution necessary. While when you look at the math behind, you need not a very big surface to create quite a good attachment to the base material to actually have safe operation. When we look into the other types of anchors, we have basically three types of working principles. One would be friction anchors, which are all the drop-in anchors which you put in and spread by hammering on it with the setting tools fall under that category. You have bonding anchors, which are mostly chemical anchors, where you actually fix it by chemical agents like resins to the concrete, and they're keying or mechanically interlocking anchors, which are producing an undercut when you actually set it, or which are concrete screws where you also have interlocking with the concrete. So that's the three principles. What they require in order to precautions when we set them, I'll touch upon later. Now, what is extremely important, and this is what we need to consider, is that the borehole cleaning matters really in most of these types of anchors. So when we look into the diagram on the right, you see that with hole cleaning, the holding force of the anchor is much higher than without. So I would actually recommend that in your companies you would look into that fact and make sure that all the operators actually are following proper procedures here, because really on the most used anchors, which are the drop-ins, also the anchors I personally like most, here it really matters to clean the borehole according to what the manufacturer says, because the holding force of the anchor is factor 2 to 3 higher, and we see that already when we looking in the loads of the application, that the anchor loads, the tolerable anchor loads, and what the application actually does have not a very, very high safety margin. The borehole cleaning actually is necessary for the friction anchors where it is kind of obvious, right? Because if you have something like something in between, like a wet dough on the table will always stick, but if you put flour below, it will always move on the table. So that effect is clear to everybody. On the bonding anchors, the same thing. So if you're bonding to dust, your anchor might not hold very well. On the keying and interlocking is not so clear, but there you can imagine that if you have dust in the hole, that the spreading of the anchor in front is actually limited. Or when you have still dust left, when you put in a concrete screw, it just cannot compress that concrete dust which is remaining enough. On the concrete screws, therefore, it would actually be enough to drill a deeper hole where all the dirt can go, basically. But on the other two anchors, a proper cleaning of the hole is of absolute essence. A little word on safety factors. What you see here is actually on one side is the action, so the force which is acting on the anchor, and the resistance of the anchor given by its design and the setting procedures. So the action describes actually the loading conditions. Characteristic action is the load applied under standard conditions, which means in our sense the correct choice of gear for the Corvid, favorable geometry of the equipment, good setting of the anchor, and everything abuse unfavorable geometry, wrong gears are increasing the load and require reconsideration of anchor size and type. The resistance of the anchor is actually what it can withstand. And you see here that according to the European technical approval of anchors, you see very few points here. The mean ultimate resistance is actually if everything goes well. If you set the anchors in the best way, if the concrete is exactly like specified and everything goes right. And then we have things which are really limiting the efficiency of an anchor, which are environmental conditions, temperature, durability, the concrete conditions, which would define the characteristic resistance. So what typically an anchor would hold. And then come the safety factors in place, which we all need for the design resistance. So that is how an engineer can design an anchor for eternal, means in our case 50 years of loading concrete. And below that, we have the recommended load, which is typically used to specify an anchor for durable fixation. What we are using to specify our anchors for the temporary fixation is the characteristic resistance. So something which is much less safe than the recommended load. So the load we allow to be applied to anchor is much higher than the recommended load. And that should all give us an idea that there's not a lot of safety margin in whatever we do. And this is why I would recommend you to really reconsider using, for example, half-inch drop-in anchors or 12mm anchors for large coring applications, because the force of the coring tools, mainly, as we have heard before, on small bits, are really leading to an overload of the anchor and are, I would say, dangerous. You see it here again, when we look at the characteristic load of a drop-in anchor, you see that it's very small, I see here, but when you look at the presentation later on, you see that an M12 HKD is having a characteristic resistance of 9 kilonewton and the M16 of 16 kilonewton. And these are the values we have seen it exceeding in the coring application and actually reaching in a sawing application already. When you go to the lowest table here, you see actually the recommended loads, and the recommended loads, they are much lower than the load we actually apply for diamond applications. And clearly, these are the loads you have to calculate with if you want to have safety factors in, and if you want to have not temporary but long-term fixation on an anchor in a building, for example. Now, there's a second thing we need to consider, and probably all of us have experienced it when we're setting an anchor close to the edge, right? It might lead to spalling, or the anchor just comes out again, or if we are setting anchors close to each other. This is why, for example, we cannot use the drop-in anchors which are spread by a hammer for fixing a console, because that would setting the anchors as close together as the console allows would actually damage the concrete and not give us additional safety by having like 3 or 4 anchors, but lower safety because they're close to each other. The edge distance on the x-axis you see is for the drop-in anchors relatively high. So it's 17 centimeters for an M12, and it's 23 centimeters for an M16. And in practical, it means we have to look at edge distances or distances between anchors, which is one hand wide for an M12 and 2 hands wide for an M16. And then we have all the other anchors, concrete screw, chemical anchors, and stud anchors, where you see that we can have much closer edge distance for a concrete screw up to 50 millimeters from the edge, which requires typically, we would say, like 12 times the diameter of the anchor. So we can go much closer to the edge with those kind of anchors. And if you have to do something, for example, on the stairs, where the distance, we can choose how far to go away from the edge. is limited by the width of the stair, we probably have to use concrete screws or chemical anchors in order to fix our equipment, and have to leave the HKD or the drop-in anchors we are using at home for that day. For the setting procedures, I've named it, and there's one thing I just want to share with you. When I'm doing a training with newbies in our company, newbies typically account managers who have been in building construction for quite some years, and they come into our trade for dealing with the heavy diamond and the diamond contractors. We make them set anchors, and we are amazed how little knowledge they have on setting anchors. So the first part of a half day of any training we do is actually making sure that they can set anchors. And you probably should give it also a consideration when you look at your operators to make sure that this is properly done. Because if you don't set properly an anchor for coring or sawing applications, and setting means they're drilling the hole deep enough, it means blowing out the hole and not forgetting about that, your safety margins are really, really getting small for the application. So anchor setting, cleaning, a very important part of the whole thing here. When we look about the concrete failure, and here we talk about how a failure looks like if the setting has been okay. If the anchor is just pulled out, as you can see, if you're setting a drop-in anchor without proper hole cleaning, that can be seen by anybody looking at it that the anchor was not set right. If something goes wrong in an application and something is damaged and the picture looks like that you have a concrete breakout where a big cone is hanging on the anchor, an anchor pull away where something is actually hanging on the anchor, like the second picture, a shear rupture of the anchor steel, a tensile failure of the anchor. These are all anchor failures which you will never see in your applications. And if something happens, in most cases, you'll see just a proper pull out of the anchor where the concrete is undamaged and the anchor alone, naked, basically comes out of the anchor. That was an application failure. Failures of the anchor otherwise look very different, with the last one being the edge breakage, which already happens when you set the anchor, not only when you load it, right? But that you have covered by getting proper edge distance. So failure modes can post-mortem, so when the thing has happened, can always be assessed if it was a setting failure or an anchor failure. And all failures I've seen actually in applications where we had rails or tools coming off the wall were operator failures. So that is something I would actually put close to your heart to make sure that this is done properly. Now, the recommendation for what to use on coring and sawing are very, very short to mention. So on a coring tool with less than 2.5 kilowatts, we would recommend to use an HKD M12x50 anchor, so a half-inch drop-in. On coring tools with more than 2.5 kilowatts, we clearly recommend to use a M16 or 5/8 anchor in all these applications. On applications in masonry, aerated lean, or concrete or natural stone, we actually would actually recommend HIT MM Plus or HIT HY100 anchors to be set. When we go into sawing applications, then I see here that's okay. So I've seen a mistake here in that slide. Just a second. So we would recommend where it says the DD tools with less than 5 kilowatt, 2.5 kilowatts. On the wall sawing application, we would recommend an M12x50 anchors, and on the wire sawing application, we would recommend an HKD M16 anchor in order to be safe. And for both applications, through bolting or HIT MM Plus or HIT HY100 for the use in masonry, aerated lean, concrete, or natural stone. Now, as a summary, the safety factors for temporary fixations are minimal, and the choice of a good quality anchor is advised in combination with proper setting procedure. So the anchor needs to be able to handle cracked concrete, which is very advisable because you know the conditions of concrete you're coring with. In coring and wire sawing applications, we face one anchor taking the load, so we have no redundancy. So generally, it's advised to use M16 or 5-inch drop-in anchors. And to remember here, small corbettes make higher loads. On wall sawing applications, we generally are less critical due to two anchors and with some redundancy. Here we are recommending M12 or 1/2-inch drop-in anchors. And what we can clearly say, we recommend that you actually do some tasks in your companies, and that would be writing anchoring guidelines for your operators and provide and document operator training. I'm sure if I'm talking for my company, our local guys would actually help you doing that. And I believe this makes you safer in operation and makes you more professional in the way you go about your work. With that, I'm closing actually quite on time that presentation, and I think we are now open for questions.
Thank you. Thank you very much, Martin. Very educational presentation, to say somehow. Very educational, very practical and to the point. I have to mention a couple of things before we start with the Q&A. First, that everybody's invited to leave questions on the chat. Please feel free to leave any question or comment. I also have to mention that the presentation that Martin made is based on a general guideline that we made on the IACDS about temporary fixation on tools for sawing and drilling. If you want to go further reading, there's another guidance document, a bit more technical and more mathematical and so on, which was made by the German association together, the German Sawing and Drilling Association, together with the German Association of Equipment Manufacturers. It's a bit more theoretical and so on, but a lot of practical tips from Martin. Very, very good presentation. The first question I want to ask you, Martin, is that you mentioned the importance of sharpness on the tool. And actually, I like your example, when you were showing how to see if the tool is sharp or not. But you have a lot of experience, training people and talking with people all over the world. Do operators really understand the importance of sharpness and the connection that this has with the anchoring and the temporary fixation?
Yeah, I mean, when you and I think everybody has experienced that when you have a damaged tool, the point is that you have what we all want is when we are coring, we want to hear and feel how the corbett advances, right? And we are all operators are basically trained to press until we pull the full power of the tool. So if the tool has an indicator light, if it goes to the red, we want to stop just before that. If it's going to the knees, we want to stop only just before it goes to the knees, because then we are fast in drilling that hole. And what you clearly can see is that when you have very sharp corbett, you have to push only a very little bit until the tool goes into the red zone. But when you have a very damaged corbett or something which is really not working, then I mean you can push like crazy, or you have to push like crazy to make it advance. And everybody will come to that point where he does that, and the more extreme should I say power junkies like me, they would actually stop the tool and switch to a gear with a higher torque, which is actually poisonous for that thing, right? So it's really so obvious when you're coring, you feel when your tool is blunt, you hear that noise. Every operator hears that noise when concrete is cutting. This noise which every application makes. It's not there if the corbett is blunt, right? And then we tend to overload the whole thing, and then you can get really wrong if the concrete is not in good order, the anchor is not really properly set, or it's an M12 and the strong coring tool doesn't really work.
Thank you. Very, very practical and very informative. That you also mentioned about the importance and how critical it is when you are drilling with the smaller diameters, with the smaller corbettes. That the importance of choosing the right anchor. Can you emphasize a little bit more on this?
Yeah, I mean, I've mentioned that because it's so counterintuitive to everybody, right? We all believe that and even my colleagues, my boss, my development manager tells me that the big corbettes are dangerous. This is not true. When you look at the math, which you can do in all quietness, when you look at the presentation afterwards, you can calculate it. But the most important point, and that probably takes away a little bit this misconception, is when you think about when the corbett is really reaching what it can do. Yeah, well, it has not endless power. It has maybe 3 kilowatts, and if I'm coring a 1 meter hole, a 1 meter diameter core bit on a 3 kilowatt tool, we come really to the very limits of what that tool can do, and the torque and the pressing force become very low, right? So there's not much force left. Even on a 300 or 400 millimeter core bit, we are underloading, we are overloading the tool in a sense that there's not much power left, and it takes much longer time to drill a hole in that diameter range than in a diameter range of 50 to 200. Now, when you go to the smaller core bits, it's obvious to everybody that we always have excess power. There is excess power available, and the machine exerts that excess power to the core bit, and the core bit exerts that excess power to the anchor. This is why. So it's kind of counterintuitive. When you think it through, it's easy to understand. In that range where a coring tool has excess power, there you can pull the anchor. Where it doesn't have excess power, nothing happens. No.
Thank you. Thank you very much. Another thing that you mentioned, Martin, was the critical importance of cleaning the anchor. I mean, cleaning for the anchoring. After you drill, just make sure that you clean properly and so on. And, how relevant is this? Do people really understand this and apply their knowledge about this, or
They don't. That's why I mentioned it. It's I see very often that people are drilling the hole, setting the anchor right away, and it's really, and you can imagine it like in the example I brought. If you have a dough which you put on the table and you want to make a bread or something, that will stick to the table, right? Which is very good. But if there's flour in between, it will slip on the table, which is in anchor sense very bad. For the bread, it's good. For the anchor, it's very bad. If you want to move the dough on the table, you need flour in between. And this is basically the grease which makes an anchor slip. And that's why it has to go out. Even when you're using the screw anchors, you have to get the dust out so that you can actually put that anchor to the end in. If there's dust left, you will limit it in the embedment depth will be limited by the dust, which is restricting you from really screwing it properly in. So the dust has to go out in order to make the anchor operate in a very safe way. Very, very important.
Mm-hmm. This is a kind of a curiosity I have. Mm-hmm. How about when you're anchoring the tools on environments where you may have slurry and on the drills that you make? How about that? How do you clean that? How do you make sure that is properly clean and it's not full with slurry or whatever?
Okay, there's one funny thing I want to tell you, and this is something which everybody does once in his life. So everybody knows that cleaning the hole is very important when you have a drop-in anchor. So everybody, me including, would try to wash it out first because you have always water available, but you will do that only once. You know why? When you set in the anchor, it will always splash into your eyes when you set it, because that the residual water which is in the hole will just splash at your face. So that's the funny part of it. The other is, I mean, a very tricky question, which I will answer in a statement my company would make and a statement I do. We would recommend actually to brush the slurry off with low pressure water and the brush after the application and before it is dry. The reality is that you don't get slurry away if you don't use high pressure. And I'm using high pressure washer on everything which I can use it safely on, like blade guards, like anything which has no seal. I'm using it also on the tools, but I'm extremely careful not to come anywhere close to a joint or to a sealing part, because a pressure washer will always press water into the tool, which any repair mechanics, by the way, now for you customers who listen, can see. And then you would not have any warranty on that thing anymore, because that's clear misuse. You should not do that. So when you use pressure washers, which is the only thing how you can get it really good away, be careful. And I can give only one recommendation: do it from day one on. If you clean your tool from day one on, they will be clean until the end of the life. Concrete slurry sticks to concrete slurry. So if you let it dry and believe that you do it next day, you won't. And that's one little trick. If you want to sell your equipment at the end of its lifetime and you have cleaned it every day, clean it and then spray it with WD-40. because WD-40 will make it look new. Otherwise, you have always this grayish concrete slurry on it, and that will help.
Thank you. Very practical. There you go. Well, on your presentation, you also mentioned to be very careful when using, vacuum, any kind of vacuum technologies in any application to fix the tool. Any advice on which cases is more recommended, or in which cases you should not?
Yeah, look, I mean, if you know what you're doing, you can use it for all applications, right? I'm a fan of the drop-in anchors because they give you that additional safety by slipping a little bit before they fail. So that you can hear. On the vacuum, I use it as few times as possible, right? I've never used it overhead, because there you have to fix it with a pole anyway. So you can also right away fix your core with one of these building construction poles. That I would rather do in this case. Fixing to the wall, you have to set anyway an anchor to fix it with a chain or an additional pole. So in these applications, I really see not a lot of use for it. Downwards, the risk is quite small, and for downwards facing applications, I could recommend it. When I'm talking about wall saw applications, I'm extremely careful, right? I would take biggest precautions possible, making sure that everybody is really far away, because if a wall saw falls off the wall, it creates massive injuries and damages in a quite big area. We've seen very critical situations by people not using end stops, and it would be similar. So the whole thing would come off the wall, and the blade would still be spinning and go everywhere. So it's generally something where you have to be very safe. My advice, if you use it towards the floor and can make sure that you're far away behind the door, which you can close if things go wrong, I'd feel safe. In all applications where you have to be close to the application, I would not recommend it. So extra precaution and high alertness if you use that. No other restriction.
Thank you. That's very, very good. Thank you, Martin. On your presentation, of course, for logical reasons, you use Hilti anchors. But how about other manufacturers? Can we go to the hardware store and buy whatever is available?
Okay, yeah, I see that. I mean, that's something I see. I'm doing here a presentation in behalf of the IACDS now, by being affiliated with Hilti and knowing their anchors. I would tell you two things. I would not go to a hardware store, because probably those people cannot really recommend what that anchor is. So I would buy it from a reputed anchor manufacturer. And I think the loads of any M12 or M16 anchors, as I've said, should be okay. But I would look into the specifications and the data sheet of a manufacturer. There are many of them. I don't want to mention names here, but go to your reputed anchor manufacturer, select the proper size of anchor, as we recommend M12 or M16. I mean, just to say that we also in our instruction manuals do not recommend to use Hilti anchors. We just recommend to use a size of anchor which are corresponding to the load values we actually are allowing on our anchors. So go to a reputed manufacturer, most probably best to a direct salesperson, and buy it from there to be sure that what you buy here is actually the best you can do.
Thank you. Thank you for sharing, a very, very clear message that makes sure that what you are using is for the proper application. So thank you also for that. Every time we talk about anchoring, we tend to say on the industry anchoring, and you mentioned very clearly at the beginning of the presentation that this is for temporary fixation of the tools. So I want to kind of ask you a delicate question. So why is anchoring such a delicate topic for the industry in general, and even for the anchoring manufacturers? Because Hilti, you guys, you manufacture anchors for all applications. So why should we be very careful with the topic of anchors? And today we're talking about anchoring of the tools, but this is not the same for other applications.
Yeah, liability. liability, I can give you here some examples. I mean, we are facing extremely high liabilities when anchors are used in sensitive environment and are not properly set. So there's a case in a nuclear power plant somewhere in the world where an anchor specified for that nuclear power plant was not set properly, and the power plant had to be switched off. And only the missing income from per day where it was switched off was $1 million. So the liabilities become extremely high. Secondly, an anchor is designed for a minimum life of 50 years. And when you're using anchors, you can imagine that when you have high-rise buildings, which are hundreds of meters high in Manhattan, they're using Hilti anchors to hold the facade plates in place. If a facade plate is falling down from a building and is hitting the ground, this is a very, very dangerous case. So there we have to make sure that everything we do is actually properly specified and fastened. Now, in our case here, we're talking about temporary fixation because all the safety factors we are building in for these long-term fixations are neglected. And what bothers me, and this is why I also volunteered to make that presentation in the first place, is that we are, and many of our customers are acting like we would have endless safety, right? But we are using already much reduced safety than any engineer would allow us to do. So we reducing safety factors, which are by a factor of 4 lower safety than for a temporary fixation. And then we are using half-inch or 12-millimeter drop-in anchors for applications where they really are not suitable to save 40 cents per day. So this is really something I cannot understand because it is our people who are on these job sites. It's our coring tools falling off scaffoldings and probably damaging other people on the ground. It's our toes where the tools fall on. And I don't really trust my safety shoes if a 40-kilogram coring rig is falling on my toes. So that's not the proper thing I would like to see. So we are for very little money actually risking our health, and that's something I really can't understand.
Thank you. Thank you for being so transparent, Martin. At the end of your presentation, you made a recommendation, and I think we're going to talk internally within the IACDS to see if we can make something like a list of top do's and don'ts for operators on the site when it comes to temporary fixation of the tools. Let's see if we can do something simple, easy to use that the contractors can give to their operators on a practical way. We'll look into this because I think it's a very good recommendation to have something simple, and with the help of the manufacturers, maybe we can do something.
Exactly, that would be good. Yes, and it would also be good to have a I would say now here non-manufacturer specific thing, because I believe it's about the safety of our industry, and here I would like to, as I've said it always, also when we did the brochure some years ago, that we should have something where everybody reconsiders, and I know that people who are not so much affiliated with anchoring often underestimate this, right? We've seen that already when we discussed it back at that time.
Okay. Thank you so much, Martin. We really appreciate your cooperation. This video will be available later on the IACDS website. I don't know if you have any last closing remarks before we finish the webinar.
No, I think we've discussed now a lot, and I hope everybody has enjoyed it. And thank you for hosting us here.
Thank you. Thank you very much. And thank you, everybody, for participating. Please remember to fill out the survey that we send after to continue to improve. Thank you, Martin, again.